Hello guys, in this video we will be discussing the problem Doraemon from January Long Challenge 2020. Let's read out the problem. The problem says Doraemon has a matrix with capital N rows numbered 1 through n and m columns. Right. Let's denote the element of row I in column j by a I comma j. Right. Next, let's define a sub-row of row small r as a sequence ar comma x ar comma x plus 1 up to ar r comma y. This simply represents the sub part. This represents the sub row from some column number x to column number y. Right. For some x comma y, let x y lies between 1 to m, and sub column of column c we denote by ax comma c, ax plus 1 comma c up to ay comma c, where x plus 1 up to y represent the rows for the given column, right? So this is how a sub-row and sub-column is defined. Now you need to find the number of pairs, sub-row of some row, sub-column of some column, with the following properties. These properties must satisfy. Okay, so first property, both sequences, the sub-row and the sub-column has the same length. First of all, the sub-row and sub-column should have the same length. Second thing, this length is odd. This length should be odd. Third thing is that the central elements of both sequences are the same. They correspond to the same element of the matrix. Alright, what does that mean? Actually, it means that the column and row should intersect at one point, which act as a central element. Right. All right. And the fourth thing is that both sequences are palindromes. Okay, let me tell you what a palindrome is. First of all, palindrome is actually any string, right? That when read from left and when read from right, it will be the same. So the well-known palindrome is Malayalam. MALAYALAM. So if you read it from left to right, it will be Malayalam, and when you read it from right to left, it will again be Malayalam, right? So this is a palindrome of odd length, right? Odd length, right? Where y is the element about which all the elements are same. L, A, M and M, right? This is how a palindrome is formed of odd length. For even length, all the elements from the starting, if y is replaced with BB, right? B and B, then it will be a even length palindrome. So everything should be same from the origin itself, right? Right. First of all, the inputs, they are going to some test cases t, and for each test case there are going to be two space separate integers n and m, which represent the number of rows and number of columns in the matrix. Now the n lines, it means we will print all the rows, the elements in all the rows, right? Is going to be m space separate integers, that is elements in each column. In each, actually n lines represent the elements in each row, right, which are going to be equal to m, that is the number of columns. All right, and we need to output the number of valid pairs. Pairs means the sub row and sub columns, which starts from which meet at a central point which is common to both, and the valid pairs are those which are palindromes, right? This is all we want. Considering that there are 100 tests, there will be 100 test cases, and n and m are given greater than equals to 1, and their multiplication is less than 10 to the power 5. Every element in the matrix is greater equal to 1 and less equal to 10 to the power 6. Now the sum of n into m of all test cases does not exceed 3 into 10 to the power 5, right? All right. So let me tell you how this problem can be solved. So this is how a palindrome is defined. Now talking about this problem. All right, so according to this question, we will be having a matrix Let me draw a matrix. It is a matrix of 5 cross 5 size, a 5 cross 5 matrix, right? Now let me also index this matrix 1 base 1 2 3 4 5 1 2 3 4 and 5, right? So in this matrix, first of all, each and every cell of the matrix will give us valid pair of sub row and sub column, which are having the same length, odd length. They are palindromes as well, right? So first of all, the answer is going to be equals to n into m, which is the size of the matrix, number of rows and number of columns, right? Now for solving the problem, we will start from these 2, 2, and we will go until we will start from 2, 2, and we will go until n minus 1, m minus 1, that is this corner element. Why we are not going to these boundary elements? Reason being that they will not gonna help us to find any other valid sub row and sub column pair, because we cannot go out of the bounds of the boundary to check whether there is any other length palindrome, right? So we will start from here and we will go to every other cell in this way, that is scanning every row by row, right? In this way we will go to every cell and we'll start from the the elements above and below it. If they are equal, then it is a valid palindrome. If these two that is in the row column are also equal, then this is also a valid palindrome. Then if this is the case, then we will add 1 to our valid pairs, that is answer will be increased by 1, right? If this happens, then we increment the value by 1, that is we will check for elements 2 above and 2 below it, and 2 left and 2 right for the column case. So in this way we will increment the counts of answer. This is how this problem can be solved. You can also understand this by an example. Let me take an example. Let's say we are considering this cell, how to compute the number of valid pairs of sub rows and sub columns for this particular cell. Let's say there is A, there is B placed over here, there is a B over here, there is C, there is C here, right? It is a E, it is a E, it is a F, but there is some D value, right? Alright, so first of all, we have already included the single element, this cell itself, right, in n cross m. Now we need to check for the length greater than 1. So we will check for these two above and below. They are both B, that is m of let's say that this cell is 3, 3. So we need to check for 2, 3, m of 2, 3. If this is found to be equal to m of 4, 3, right? If these two are equal, and along with that these values C and C, that is the sub row is also equal, that is M32 is equals to M34. If both these conditions satisfied, then we increment the answer by 1. Why? Because they are both palindromes, they are right having odd length. So this is how we need to proceed. After that we need to check for these E and E, but these F and D are not equal, so we will not increment the count by 1. We will move to the next cell. So this is how this problem can be solved. Let's move on to the code. I'll be writing the code in C++ language. This library bit/standard C++.h includes all the libraries, that is the headers of all the libraries in our code. So there is no need to worry about the headers. Okay, so there are some test cases. Now for each test case we are having n and m variables as input. Alright, let's name a matrix map with size n comma m. Let's take it as m plus 1 comma m plus 1, n plus 1 comma n plus 1, because we will take index from 1 comma starting from 1, not from 0. Alright, now we will take input for, let's start from 1, I less than equals to n plus plus for int j1, j less than equals capital M, and j plus plus. Alright, we will take the input of the matrix n lines, matrix ij, right? Alright. So after that, all I have told you that go to every cell from 2 comma 2, right, to I less than n, I plus plus, or int j equals 2 and j less than m and j plus plus. What you need to do here is that first of all take a variable answer which is equals to n into n, right, for every single cell in the matrix. Now from here onwards, if you find out that if matrix element I comma j minus 1 is equals to matrix element I and j plus 1, right, also matrix element I minus 1 j, that is the sub rows or sub column, is also a palindrome. We need to check here with I plus 1 and j, right. If this is so, that means this is a palindrome, then we can add 1 to our answer, or simply say answer plus plus, right. If this is not the case, that it is not a palindrome, then simply we need to move on forward, and we need to do it till the time while, let us take a variable integer x equals to 1, right, and subtract that x from here. Why? Because every time we need to either we need to move in the away direction from the central cell, right, at which we are at present. So we will do answer plus plus and x plus plus, because this will help us, right. If this is not the case, then we will break. Why? Because this is not going to be a palindrome. We need to move to the next cell in the matrix, right. This is up to while it is true, right, or you can say while 1, while true. Alright, so this will kind of find out the answer for us. Now we will output the answer, right. So let's try to submit this, whether we are getting a right answer or not. Let's check out. Okay, one more condition we must put, I guess, that we should not go out of the bounds of the matrix. That is one condition that we need to put here. Right, let's first get it submitted, and then we will put that condition also. yeah, that condition is crucial, so we need to put that. Suppose let's put this in brackets. All right. All right, also while true, instead of that you can say while this is true, while this statement is true. Exactly, while this statement is true, we can keep going, and when this is not true, we come out of the loop, this while loop, and set x again equal to 1, and then we will keep looping. And one more condition that needs to be put over here is that j minus x is right. J minus x should be greater than equals to 1, and j plus x is less than equals to m, and I minus x should be greater equals to 1, and I plus x should be less equals to capital N. Right. Let's try to submit this now. Guys, don't forget to like, share and subscribe my video. Stay tuned for the upcoming videos. I need your support. Let's find out whether this is a correct submission or not. All right, so this is the correct submission. We have done solved this question. You can see the next question in the next video. Thank you for watching. Stay tuned for my upcoming videos. Bye bye.